Hello and welcome back. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today is part 4 of our Titanic dataset prediction series, and we're going to be using a second machine learning model, and that is going to be the Adaboost model. Now, if you don't know what the Adaboost model is, I have made a tutorial explaining what Adaboost is and how we can use it, so go ahead and check that out. Also, if you haven't seen the first 3 parts of this tutorial, you're going to need to check those out, because I am going to be starting after we're done pre-processing all the data, and if you don't do that, then you're not going to be able to run this code. So go ahead and check those out, and for everyone else, let's go ahead and get started. Okay, swapping over to the Jupyter Notebook, you can see we are starting where we left off in the last notebook. However, I got rid of all of the code that was related to the random forest algorithm, and I stopped right after we split our data into training and test data. So let's go ahead and get started. First thing we need to do is we need to import the new algorithm. So from sklearn.ensemble, we are going to import the Adaboost classifier. Go ahead and run that and get that in there. And we can go ahead and define our classifier. So CLF equals Adaboost classifier, the function that we just imported. And we are going to set the random state to 0. I'm just doing this so that I can repeat everything, or you can repeat everything I'm doing here, and we don't have any randomness associated with it. Next, we can go ahead and fit our training data. So clf.fit, we're going to pass it xtrain and ytrain. And then we are going to score it based on x-test and y-test. Go ahead and run that, and you can see we are getting 82% accuracy. So let's see, I think in the last video that was about what we were getting. Let's see if we can go ahead and improve that a little bit. Let's start by defining some hyperparameters. So params is going to be equal to a dictionary. And we're only going to be looking at 2 hyperparameters. First is going to be n estimators, number of estimators. And we can just define a list of a few. So 50, 100, 200, 300, 400, 500, and let's go 800, 1,000. Okay, so this just gives us a wide range of the number of estimators. And this is exactly what we did for the random forest algorithm as well. Next, and the last one is going to be the learning rate. Learning rate is how fast we are going to converge on the solution. And we're just going to change around the orders of magnitude. So we're going to start with 1. We're going to look at 0.1, 0.01, and 0.001. For now, we'll stop there. And those will be the parameters that we're going to look at. Like before, we're going to use the randomized search. So we're going to define random search as our model name. That is going to be equal to randomized search CV. That is the function that we imported from sklearn. We're going to pass it our classifier. So this is the Adaboost classifier. I'm going to fix the random state again. Okay. So we got our classifier in there. Now it's looking for the parameters. So we're going to pass those parameters that we just made. We're going to be scoring this based on accuracy. I am again going to fix the random state. Set that equal to 0. And then I'm going to do CV equals 5 for cross-validation. Okay, this has everything we need, and we can go ahead and start fitting our training data. So that would be a random search dot fit. We're going to go ahead and fit the X train and the Y train, and our model will be trained up to this point. Now, we are going to be extracting the optimal parameters that this random search was able to find. So we need to create a new variable called randparams, and we're going to have that equal to rand search dot best underscore params. Params, there we go. And those are going to extract the parameters. Now, everything I'm doing here is exactly what I've been doing for the random forest or even some of my other videos of how you can fine tune your hyperparameters. So you can basically just copy all of that code. The only thing you would need to change is the parameters up here. But we'll continue on with this. I'm going to print those parameters that I was able to find. And I'll print a divider. Next, I'm going to print the training accuracy, so the best accuracy I was able to find with the model. And I'm going to be printing that by doing a rand search best score. Okay, next, using that, I'm going to using the model, I'm going to predict my test data to see how far off I am. So that would be a rand underscore search dot predict. This is going to be predicting the X test data. Now we have our predictions. We can go ahead and print test accuracy. And test accuracy is going to be equal to the accuracy underscore score. That's another function we imported from sklearn. Need to pass to the predicted values and the true values, which will be y test in this case. Okay, after all of that, let's go ahead and run it. And this may take a second to load. So I'm just going to create some new cells down here. Now, this is doing a randomized search for those who don't know what random search CV is. So it's going to be randomly searching in the space of all of these estimators and learning rates to figure out which one is optimal. Next, we're going to be taking what we learned here and using it in a grid search. So grid search is going to try every single combination of these until it finds one. So I'm going to copy this code down and get it ready while we're waiting for it to be trained. Oh, there it goes. Perfect timing. So we were able to achieve a little bit better accuracy. So we're at 82.86 now instead of 82.12. And so we will go ahead and keep pressing. So we are going to take what we learned from here and we are going to create some new variables. First is going to be n estimators. And we are going to set n estimators to be np.linspace. We are going to take the rand params. So we're going to take the value of the n estimators that the random search was able to find. And in this case, it's the estimators, n estimators. And we are going to, all right, we're going to subtract 50 for the lower bound. And then we are going to add 50 for the upper bound. And I'm only going to do 3 of them because I want this to execute rather quickly. Next, I'm going to do learning rate. And that is also going to be np.linspace. Okay, now this one's a little harder because it's not just a fixed value every time. So this could be any order of magnitude. So what I'm going to do is instead, I've still passed rand params at learning rate. So I'm still pulling this learning rate down. But for my lower limit, I want to subtract 10%. And for my upper limit, I want to add 10%. So I'm just going to multiply this by 0.9. And then the upper limit, I'm going to do the same thing. But I'm going to multiply it by 1.1. And for the linspace, I'll do 3 again, just to make this go a little quicker. Okay, now I'm going to pass those into the parameters. Let me scroll down. Okay, so passing the variable that we just created into n estimators. And actually, I forgot one thing. So the n estimators is going to be an integer value, but this np.linspace will automatically make it a float. So you have to cast this as type int. And the learning rate needs to be a float, so don't worry about casting that one. Okay, same thing for the learning rate. Now, this is no longer a rand search, this is a grid search. So we're going to change anything that says random or rand to grid. We're using the grid search function. Everything else in here is fine, except the grid search no longer has a random state because it's checking everything. We are going to fit the grid search algorithm. We're going to pass back its parameters. We are going to print those parameters. We're going to print out the best score I was able to find. We're going to predict the test values as well. Okay, we should be able to run this, so let me go ahead and run. I do have an error somewhere, and that is because I have an extra decimal place here. Okay, now that's training, and we'll go ahead and see what it's able to find. While that is working, we're going to come up with some accuracy. Hopefully it's better than the one we had before. But other ways to improve your accuracy for this, like I mentioned in the random forest video, you can go ahead and look at the data. So maybe we need to bin our data in different ways, or maybe we need to add new features. So come up with some feature engineering techniques to give you some other feature that maybe I don't have here. Maybe there's other ways of pre-processing the data that I didn't do. Those are all methods in order to increase the accuracy more than you will by tuning these hyperparameters. What I do here probably, I wouldn't say it would be the best you can get, but it's pretty close. So you're going to get more out of feature engineering or changing the data than you will fine-tuning the hyperparameters anymore. But as we're waiting for this, this is going to be the last video in the series. You can go ahead, try other algorithms. There are a bunch out there, so see what works for you. And then figure out, maybe fine-tuning some hyperparameters of other models may be able to get you better scores than we were able to get with Random Forest or Adaboost. There's a ton of stuff out there. I haven't even run this through a neural network or anything yet, so it's possible that you could find something else. Okay, this finished, and it looks like we did about the same on the training accuracy, but our test accuracy is actually worse. So we would be reverting back to one of these other models in order to give us possibly a better score. I would have to look at also what the test data looks like that's making it perform so bad. Maybe it's just we got a bad test split and it's performing bad here, but in future predictions it would do better. So lots that you can look at for improving this. For now, though, this was just a gentle introduction into this stuff, so I'm going to stop here. If you got anything out of this series, please like this video. Please subscribe to the channel for more stuff like this. And thanks for joining me, and see you in the next video.